Hello and welcome. In this video, we're going to be discussing how to rationalize an expression like the one you see. So what does rationalize mean? Let's start with that. So when we rationalize an expression, what we're trying to do is end up with Hello and welcome. In this video, we're going to be discussing how to rationalize an expression like the one you see here. So what do we mean when we say rationalize? Well, basically when we rationalize, our goal is to not have any radicals in the denominator position. So that's what we're going to aim for. Now our restriction is that I can't just change the value of my original expression. So I have to be really careful in the way that I do this so that I'm not changing the value of what I've started with. So before we begin this one, there are a couple of background things that I just want to review. So the first thing is what a square root means. So remember that a square root is just undoing a square. So if I take a look at the first one, if I have the square root of 3 times 3, the idea is that for every 2 factors, the square root, it just tells me to keep 1. So the square root of 3 times 3 would literally just be 3. In other words, I can bring one of these 3's out, and then there's nothing left under the square root. Okay, the second thing that I want you to want to review is what happens when we multiply a square root by another square root. Well, remember that that just means whenever I have a square root times another square root, I can write this as just one big square root, where the inside part is literally just going to be the product of my 2 original inside parts. So the square root of 3 times the square root of 3 is just the square root of 3 times 3, which we just saw in step 1 is just 3. The third thing I want to review is what if you have the square root of a fraction? Well, just like we saw in number 2, whenever I have separate square roots and I'm multiplying, I can combine them into one big square root. Same idea here, but in reverse. So if I have one big square root, I can separate that into 2 separate square roots. Okay, and then the last thing I want to review is how we preserve the value of our original fraction. So if I have something like 1/2 and I decide that I'm going to multiply top and bottom by 3, we end up with different numbers on the top and on the bottom. So 1 times 3 is 3. On the bottom we end up with 6. But notice 3 over 6 really has the same value as my original fraction, 1 over 2. So what's the point? Well, the point is when I multiply top and bottom by the same number, the value of my ending fraction still matches the value of my beginning fraction. So I haven't changed the value. All I've done is I've made it look a little different. So that's kind of the idea, the big idea that we're going to be using in this problem. So let's take a look at it again. So I've got the square root of 2 over 10. So my first step is I'm going to separate this into 2 separate square roots. So the square root of 2 over 10, I'm just going to rewrite as the square root of 2 over the square root of 10. Okay, then my second step is I'm going to multiply top and bottom by the same thing. And the reason I'm restricted to that, again, is I don't want to change the value of my fraction. So if I don't want to change the value of my original fraction, I can multiply the top and the bottom by something, but it has to be the same something. Well, remember my goal here is not to have any radicals in the denominator position. So what I'm going to do is I'm going to multiply the top and the bottom by the square root of 10 in this case. Okay, why would I do that? Well, let's look to see what we have in the denominator. So if I multiply my square roots on the bottom, I've got the square root of 10 times the square root of 10. I can write that as one big square root. That's just the square root of 10 times 10. Okay, if I do my tops, again, I can write that as one big square root. So I've got the square root of 2 times 10. Okay, really nice thing on the bottom. Look at what I've got. I've got 2 factors of 10. The square root of 10 times 10, whenever I have two of the same factors, like in this case, I've got 10 times 10, the square root of that just becomes 10. Okay, that's really what the square root means. It's really undoing squares. So on the top, I've got the square root of 2 times 10. Okay, well, here I do want to try to simplify that square root a little bit. So the square root of 2 times 10, well, what I know is that 10 factors into 2 times 5. And then notice that I've got 2 factors of 2, which means I can pull a 2 out. So what I'm left with if I pull a 2 out is I've got 2, and then I still have that 5 left underneath because I've only got one 5 there, so I can't pull any 5s out. On the bottom, I still have 10. And now I'm left with a fraction, and notice that on the bottom there are no square roots, and that really was my goal. The only thing that I can do left is I can simplify the fraction that I have. So notice I've got a 2 on top, a 10 on the bottom. Well, I could divide top and bottom by 2. So if I divide top and bottom by 2, this guy on top becomes a 1, the guy on the bottom becomes a 5, and my final answer would be 1 times the square root of 5, which is just the square root of 5, over 5. Okay, so I want you to try this one as well, just to make sure that you are on track. So pause the video. I want you to rationalize this expression, and then restart the video after you've given it a try. Okay, so if we look at this guy, again, I'm going to take the same steps as before. So the top, I'm just going to write as the square root of 3. On the bottom, I'm going to write that as the square root of 15. Okay, then what I'm going to do is multiply top and bottom, in this case, by the square root of 15. Okay, why am I doing the square root of 15? Because I know then on the bottom, I'm going to have the square root of 15 times 15. And what I know is that when I have the square root of a square, I just end up with plain old 15. On the top, what I would have is the square root of 3 times 15. So if we simplify this, again, the bottom just becomes 15, because for every square, the square root sort of undoes that, so I'm just left with the 15. On the top, I'm left with, well, 15, notice, does factor. 15 really factors into 3 times 5. So I'm left with the square root of 3 times 5 when I factor out the 15. And then notice there I can pull out a 3 because I've got 3 times 3. So for every 2 factors, I can pull 1 out. So I can pull out a 3. And then what's left underneath is a 5. On the bottom, I still have 15. So if you look at my expression, it's definitely rationalized because I don't have any radicals in the bottom. The last thing I want to do is simplify the fraction that I have. So 3 is a common factor to both the top and the bottom numbers. So if I divide top and bottom by 3, I get 1 over 5. So my final answer is actually going to be square root of 5 over 5.